Okay, so for this lesson, we're going to simplify radicals. We've been doing that all along, but now we'll do it more with division, and we're doing something called rationalizing. Don't forget that in order for a radical to be in simplest form, there can't be any perfect square factors other than a 1 under the square root symbol. You can't have any fractions underneath the square root symbol, and you can't have any square roots in the denominator. And this is what we're going to work with today, is having to make sure there's no radicals in the denominator. By doing that, by making sure there's no radicals in the denominator, that's what's called rationalizing. And the way that you rationalize a radical expression is you're going to multiply both the top and the bottom by whatever that squared on the bottom is. This eliminates the radical, and then you're going to simplify. So the idea is, I'm going to throw up a new sheet here right now, but what you should understand is any square root times itself is just that number with no symbol. For example, radical 2 times radical 2 using the product property is the square root of 4, but the square root of 4 is just 2. And like radical 5 times radical 5 becomes radical of 25, but that's a perfect square whose square root is just 5. Radical, let's say 11 times radical 11 equals radical 121, but that's just 11. So the idea is by multiplying any square root times itself, the answer is just that number with no radical symbol. So I have no idea what 37 times 37 is. I have no idea what that answer is, but I know that root 37 times itself is just plain old 37. And that's really important when we start doing this rationalizing stuff. So this first particular one, we need to simplify. We can't have the square root of 2 in the denominator. So what we just talked about is if you multiply the square root of 2 by itself, you no longer have a square root anymore. But whatever you do to the bottom, you have to do to the top. Well, what happens on the bottom is you really get the square root of 4. I'll do this once, which really is just 2. On the top, I've got a 1 outside the square root of 2, and I can't really multiply those together. 1 times radical 2 is just 1 radical 2. All that I will do is just eliminate the 1 there. The 1 you can either use or not use. It's up to you. But bottom line is we have a fraction. That's okay. But there's no fraction in the denominator, and there's no fraction under the square root. Let's see if we can try the next one. So the next one is square root 8 divided by square root 5. We need to get rid of the radical in the denominator, so we're going to multiply both top and bottom by that square root. The whole reason why we're multiplying radical 5 by itself is to get rid of the radical and just have the number. On the top, by the product property, it becomes radical 40. Well, I got to go back to the first day of radicals. Under 40 is a perfect square. I know that 4 times 10 is another way to get 40, and I also know that the square root of 4 is just 2. So my final answer here becomes 2 square root 10 divided by 5. That's all I can do. If I wanted to try to simplify further, I could only simplify both things out of the radical, and those don't divide evenly at all. So we're done. It's 2 root 10 over 5. Next one, I need to get rid of the square root of 18 in the denominator. So I'm going to rationalize. I'm going to multiply both top and bottom by the square root of 18. On the top, I just get 3 times the square root of 18. On the bottom, the square roots disappear and I just have an 18. Well, there's a couple things that you can do. You can simplify the outside numbers first, or you can simplify that square root. Doesn't really make a difference. I guess maybe we'll simplify first. So what if we were to do this? 3 over 18 is just the same thing as 1 over 6, right? 3 goes into itself once, goes into 18 6 times. Again, I can't lose my radical of 18. But there is a perfect square under 18. I'm going to come over to here. So I've got 1 square root 9 times square root 2 over 6. The square root of 9 is just 3. 1 times 3 is 3. Square root 2 over 6. And again, I've got these numbers outside the square root that simplify. And then that becomes 1 square root 2 over 2. Because 3 over 6 is 1 over 2. Again, if you don't want the 1 outside the radical, you don't need it. It can be there, it cannot be there, it doesn't make a difference. Let's try the last one, number 4. I need to get rid of the denominator of radical 6, so I'm going to multiply both top and bottom by radical 6. The 3 is on the outside of 2 radicals that multiply to give you 48. It's all over 6. I could simplify 3 over 6. I'm going to wait to the end. So this time what I'm going to do is I'm going to break down my radical 48. I'm going to come over here though. So I've got 3 square root 16 square root 3 over 6. The square root of 16 is just 4. 3 times 4 is 12, rad 3 over 6. And again, I'm going to simplify it now. I could have simplified before. It won't make a difference. 12 divided by 6 is just 2. So your final answer is just 2 rad 3. Okay? Good luck.